Welcome back. In this video I wanted to talk about estimating a population standard deviation with data from a sample. Now, what is a population standard deviation? If I recorded the ages of all 4,312 people who work for the federal government, and I plugged those 4,312 ages into a standard deviation formula, the answer I would get would be a population standard deviation. It would be the standard deviation of the ages of all people in that population of federal government employees. And we, just like how we can't usually calculate a population mean, we usually can't calculate a population standard deviation. And the reason is because in order to calculate a population mean or a population standard deviation, you have to have data from all members of the population. But just like how a population mean can be estimated with a sample mean, a population standard deviation can be estimated with a sample standard deviation. So let's imagine that instead of recording the ages of all 4,312 federal government employees, which is what we would need to do to calculate the population standard deviation, what if we instead recorded the ages of a sample of, let's say, 100 federal government employees, and then plugged those 100 ages into a standard deviation formula? Well, if we did that, our answer would be called the sample standard deviation. It would be the standard deviation of a sample. And if we did that, where would our sample standard deviation fall? Would our sample standard deviation fall near the population standard deviation, or would it fall further away from the population standard deviation? In other words, would we be highly accurate in estimating the population standard deviation, or would we be highly inaccurate in estimating it? Well, whenever you record data from a sample, or at least from a random sample, the sample tends to have less spread than the entire population that it comes from. The reason is because samples tend to not capture enough extreme values. So that's why samples tend to have lower spread compared to the entire population. So because of that, you might be thinking that our sample standard deviation would be likely to come out somewhere down here, and that this would be more likely. You might be thinking that a sample standard deviation up here would be less likely. And it would make sense to think this way because if a sample tends to have less spread than the population it comes from, then you would think that the sample, which has less spread than the population, would have a lower standard deviation, and you would think that the population would have a higher standard deviation because of having more spread. And that thinking makes sense, but there's actually an adjustment that's done to a sample standard deviation that corrects for this. It actually corrects for the tendency for a sample standard deviation to underestimate the population standard deviation. So what if we calculated a sample standard deviation and we didn't adjust it? We just calculated it the same way we would calculate a population standard deviation. Well, we would have a tendency to underestimate the population standard deviation. Our sample standard deviation would be likely to be somewhere down here in this area. But because of this adjustment, what the adjustment to the formula does is it raises the sample standard deviation to a higher number, which eliminates this tendency for a sample standard deviation to underestimate the standard deviation of the entire population. And you can just let me know if you have any questions about the point that I made in this video, or the points that I made in my other video. See you next week.